All right, we're back. All right. Okay. Hello, everybody. Hello. Hey, Gustavo. My dude, how are you? How are you? All right. Let's get to this here today. Alrighty. There we go. And we got it. Okay, how we doing today, everybody? I'll see my crew coming out. Pretty good, Sono. Pretty good, my friend. There we go. It's been a good day so far. Diego, how's it going? How is it going? Pretty good, pretty good. It's been better good. How many classes do I teach a week? Currently, uh, currently online I got 5, but really in reality I have 6 sections, and I'll have 7 classes for the whole semester. So, um, yeah, it's quite a bit. Definitely keeps me occupied, that's for sure. Definitely never gets boring either. Ivan, my dude, how we doing? Towel, how are we doing today? I hope you're doing very well. Thank you, sir. Thank you. I am so happy you're in a good mood today. That's a good thing to hear. Yep, it is Twitch is designed that way. Hey, Civil, how are you, my friend? Yep, I make sure that I put a push notification so you know when to come on. Sometimes I'm running a bit behind. Tal, what you do this? What you been up to, Tal? Look. I understand that. It's fine. You're joining right now. Look, you're talking. You're doing stuff. Maybe you're working at the same time while you're listening to my stupid face, and it all works out in the end. There you go. Everybody's a winner. I don't mind at all. One hell of a road trip. Where'd you go, buddy? Went on a one hell of a road trip. It better be a hell of a road trip. Hmm. Probably will replace that eventually. West Virginia. West Virginia is really beautiful. I've driven through West Virginia, and actually, when my friend was down in West Virginia at one point and visited him down there, it's just, man, that is a beautiful area. You could drive around there all day. You just like relax and, yeah, it's super chill down in West Virginia. Say what you will about West Virginia, but West Virginia's chill as hell. I love West Virginia. That's a nice place to be. That place is great. All right. Oh, hey, we gotta do stuff today, man. Holy moly, we gotta do things. Whew. Oh no! Shoot. Yeah, your truck broke down. Oh man, that sucks. Especially within West Virginia, you got a lot of hills, so yeah, up and down is yeah, that's pretty bad. Did you get it fixed though? Hopefully, it didn't cost you too much if you got it fixed. And I'm glad you made it back in one piece. That's good. All right, that's good, man. Safety is number one. Gotta do it. All right. I think it's time we get going here, so let's do it. All right, so. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today, we're going to continue moving forward here with the material here in Chapter 8. Okay, so Chapter 8 is the next thing on the docket. We're going to finish up Chapter 8 here today, doing the last three sections here. Actually, I should mention here. Oh, right, I do have to mention that. Actually, last couple of sections, and then maybe section 9.1. Let me go ahead and make a note about this because I kind of forgot about this. We're skipping section, specifically, we're going to be skipping section 8.3. Okay, so you will not see any homework related to section 8.3 at all. Okay, so just letting you know, we'll be just kind of doing 8.2, skipping 8.3, and then just kind of moving forward there. Hi, Tracy, how are you? Did you get my email there, Tracy? Make sure you got my email there. Okay, cool. Glad you got, glad that worked out. Are you feeling better? I hope, I hope all that nastiness is now set aside, or at least a little bit anyway. Well, I'll take so-so. Well, okay. I'll be honest with you, Tracy. I'll take so-so over what you sounded like last week. That was brutal. Did I ever hear back from Shaq? Yes, I did actually. I did, and did a little more digging, and it really sounds pretty legit. So yeah, I did actually. Yeah, I'm just glad you're feeling better, Tracy. That's what matters, your health. Health's important. That's all that matters. I was surprised too. Actually pretty legit. You guys were right to be skeptical, but I had to do a little more digging and be like, okay, is it really sus, or is it just like, you know, what's the story? Did I donate? Yes, I did. It was legit, and I'll. That's fine, Tracy. You take your time. Had to donate. Got to follow through with my promises, so that's important. Integrity, important. I know you guys are looking at me like you're crazy, and be like, maybe I am, but if I say that I do something, I usually do it. So unless I have a reason not to. Guys, got any other questions before we start here for today? No? Okay. Let's go ahead and get going here for today then. All right. So today we're going to go ahead and start here with section 8.2, which is talking about perimeter of polygons and the areas of quadrilaterals. All right. Well, let's talk about perimeter here. We'll talk about perimeter and area quadrilaterals. Okay, so perimeter by itself is pretty simple, right? All you have to do is take the sum of all of the lengths on the outside of the, in this case, 2D figure, and that's essentially what the perimeter is. I think most people are pretty aware about how that works. That's not too hard to figure out. Um, pretty straightforward. But let's go ahead and do an example here with perimeter, and you know, I'm not going to spend so much time on perimeter here, but it may be important in the grander scope of the problem here. So we're gonna take a look at that, of course. Okay, so let's look at number 9 here. So number 9 here on this bottom left-hand corner says let's find the perimeter of this figure here. All right, so in this particular case, if we want the perimeter here is going to equal 3.77 plus 8.07 plus 4.82 plus 6.15. All right. Again, I fully expect you to use the calculator for that, just to get your answer there. So it shouldn't be too hard to do. That was something I did yesterday. Okay, and so our answer here is 22.81, and this is going to be inches. Okay, so that's what we get here for the perimeter of said figure. That part, as you can clearly tell, is not so hard. You're just adding up those outsides. Simple dimple. Let's do one more, though. Just one more, really quick. Um, what about number 12? Actually, it would be great if you guys could see number 12. So let's move that around a little. All right, so what about number 12? what would the answer to number 12 be? What would be the answer to number 12 here, as you can see in the bottom right-hand corner? All right, 26.4. All right, that's correct. All right, so all you have to do here and recognize is that 8.5 is just the length of this whole side right here. It doesn't matter what these lengths are, right? It only matters like this whole side is 8.5 and this whole side is 4.7. So again, I don't know what these lengths are, but it doesn't matter. They'll always add up to 4.7. And since there's two lengths and two widths, then you can see where we're going with this. 8.5 plus 4.7 plus another 8.5 plus another 4.7. Okay, and absolutely correct here, 26.4 looks like inches for this. All right, so there we go. Not hard to get perimeter. This is probably the only two examples I'll do for perimeter, as it is not that important for at least quadrilaterals here. We'll, of course, look at perimeter um, for like circles later on. All right. Okay, so the main point here, of course, is not the perimeter here, because that's pretty simple and straightforward. The main point here is actually the area. Now, the area formulas here are going to be what we need to be focusing on here, because, of course, we're talking about quadrilaterals, so we have different types of quadrilaterals that have different types of area equations. And some of these you've seen before. Some of these it's been a while, so which I completely understand. So let's go over our area equations. All right, so area formulas. All right. So let's do which one I want to do. Yep, that's fine. Okay. All right, so the first two here are going to be things that you've definitely seen before in some form or fashion. So let's at least put that one down. Okay. Oh, that's how that works. Okay, that's fine. Okay. All right. So the first one you've probably seen hundreds of times here. The first one is going to be a square. All right, so here's the square. Yay, that's great. All right, so maybe I can add a little text here. Yeah, let's do a square. Man, that looks good. All right, so if we want the area here specifically, all right, then we have a side here for a square. Again, every side for a square is the same, as you know, same sides. So area here equals s squared. Okay, so just s times s, no problem. Easy peasy. Okay. Now a square is just a subset of a, hey, Miguel. No, that's okay if you're late. No problem, my dude. Maybe you're busy. No worries. All right. All right. Next, let's talk about, darn it. Why do I always get that wrong? All right. Let's look at rectangles. Actually, I'm not sure why I didn't use this before. Look at that smiley face. Yay. Bam. I'm getting better with this thing, okay? I'm getting better, all right? I'm getting better. All right. Today I've learned new things. Okay. So, today I'm still learning new things. All right. If I can figure stuff out. No, why? Why would you do this to me? Don't do this to me, please. Oh, I'm gonna eventually get this. Hang on. All right. If I don't, all right. You know what? You don't like that? Okay. I'm gonna try one more time. One more time. Okay, there we go. Okay, so let's go with a rectangle. We're gonna. Okay. So rectangle, as you know here, we have a length. Okay, right down here, we have a width. All right, so we have a width. Okay, so as we're pretty familiar with here, area is going to be equal to length times width. Okay, so length times width will be our area, no problem. Okay, fairly straightforward. Okay, easy peasy. All right, let's look at the next one. So those two are ones that you've seen probably hundreds of times before. I don't think you'll have a problem with that. But there are a couple others that certainly you may not have seen in a while. So I wanted to kind of focus on that and just be like, okay, how do we deal with those kind of quadrilaterals per se? Okay, let's see if I can see if they have a picture of that here. And the answer is no. Okay, I guess I'll have to go to the brush then. All right. So this next one here is a shape that you may remember from the past, but again, if you don't, that's fine too. Okay, so this is our this is the shape here. All right, and the text we're going to use here, we're going to actually put something in here. So it's oh, well, that wasn't what I wanted. Oh, eventually I'm going to learn. Eventually. Today's not that day, folks, but eventually it's going to happen. All right. Put it up here. All right, so the next one here is a quadrilateral. Or actually not quadrilateral, sorry, parallelogram. What am I doing? All right, so this is a parallelogram. Now, two things about the parallelogram that you absolutely have to know here that will be important is you need to know here, you need to know the base. So the base is down here. And then more importantly, besides just the base of the parallelogram, what we want here specifically is the height of this parallelogram. So this is the height. Okay. So having this here, what's the area of this particular figure? So the area here is equal to base times height. Okay. So that's the parallelogram. Again, you don't see that super often, but again, it's one of those things that does pop up from time to time. So we do have to be aware about that. Okay. All righty. Okay. Now, let's look at the next one here. Let's see if I can make it using the tool. That's a square, but I think I can do that. So let's see. Oh, I guess not. All right. That's a pity. All right, we'll just do it the easy way then. Okay. Oh well. Thought I may have had something, but no, I guess not. In any case, let's go ahead and look at the last shape here of a quadrilateral. And so the last shape here is going to be a shape you probably have seen before, but again, maybe it's been a while. Okay, so here is our good friend. This is our good friend here. All right, so this is our good friend here, the trapezoid. Okay. Oh, whatever. All right. Did I accidentally do that? I guess I did. Let's try this again. One day I'm gonna learn. All right. Okay. Now, as part of the trapezoid here, what we want to look at here specifically is we're going to look at we want to look at three things here specifically. First of all, in a trapezoid, we can make a height here. Again, much like the parallelogram, it kind of goes down here, makes like a 90-degree angle. By the way, this is also a 90-degree angle down here when you cut it like that. So this is the height here. We'll label it as H. Okay. Same height would be over here as well. But we do have two bases here. So this is what we call the big base, or you see this labeled as, say, base 1. And then up here is the small base, or commonly referred to as base 2. Okay, so this is basically the parts of the trapezoid that we want to kind of focus on here. And so if we talk about, say, hey, let's find the area of this trapezoid. All right, so the area here specifically will equal 1/2 base 1 plus base 2, so big base plus small base times height. So big base plus small base times height times 1/2 will be the area of our trapezoid. All right. All right. Any questions about that so far? Hopefully that's pretty straightforward so far. Just kind of some information, just kind of information dump. Like, oh my gosh. All right. See if we have anything we need to do. No, not that one. Nope. Okay. All right. Now, let's go ahead and take a look here at some examples, okay? And we'll see exactly how we can find, say, the area of a figure. All right, so we'll do one, and then we'll look at the application problems. So let's go ahead and do that right now. Okay, so let's go back here. Okay. All right. Okay, so let's go ahead and do number 4. Let's do number 4. So if we do number 4, we want to find the area of this trapezoid. Okay, so can anybody tell me, let's set this up here. So we have three things that we need to find in the trapezoid, okay? So we need to find the big base, the small base, and the height of the trapezoid. And then we can put it together and find the area. All right, can anybody tell me what's the height of the trapezoid? What's h equal to? All right, 15 feet. Good. So h is equal to 15, so we got that down. No problemo. All right, cool. What's our big base and small base? All right, 42 and 14. Perfect. Nice. So our big base here, let's go ahead and just put this down here. Big base and small base. Okay, so this is here's a brief synopsis here. So here what we're going to do is that the area here is going to equal, again, 1/2 times, again, the big base plus the small base. So let's go ahead and write it down here. So the area here is equal to 1/2 times the big base, which was 42, plus the small base, which is 14. And we'll multiply that straight up by the height, which is 15. Okay, and you can bip bop boop that in the calculator there. So you get 1/2 times 56 times 15. And if we go ahead, we take 28 times 15, since that's half of 56. And we just go ahead and get our answer here. So we get 420 here. Now in this case here, one thing to be careful about is the units. Remember, this is going to be square feet. So not just feet, but square feet, since we're talking about area. Okay, any questions about that? Any questions at all before we move on? All right. If there are no questions, we'll go ahead and move on here to a application problem, and we'll see how to work that out. Easy peasy, hopefully. All right. All right, yeah, that one. Okay, so we're going to look at number 1. All right, so let's look at number 1. Number 1 is a masonry problem. So it says, how many bricks will it take to build the wall shown if a brick measures 4¼ inches by 8¾ inches, including the mortar? All right, and they give you a nice little hint here. The hint here is that we have to change the wall dimensions to inches. So if we look here at the picture on the left, we have a wall that is 7 feet 1 inches high and 35 feet across. Okay, so what we need to do here is we need to go ahead and change each of these dimensions we see here into inches first. The only reason why we need to do that is because our bricks measure in inches and not in feet. So this is one of those problems that we had talked about before where context definitely changes. Okay, the wall is expressed in feet, but our bricks are expressed in inches. So we want to make sure that we match up the contexts here so we can do the proper calculations. Okay, so let's go ahead and see how we can met this out here. Okay, so let's first do 7 foot 1 inch. Okay, so 7 foot 1 inch. What is 7 feet 1 inches in total inches? What's that going to be? Well, 7 foot 1 inch. What's that equal to? All right, 85. Good, right? So we do 7 times 12. Correct. Plus the 1. So we get 85 inches there. Spot on. And how about 35 feet? Since it's how long this brick wall is going to be. About 35 feet in inches. $420. Okay, good. So we get 420 inches. All right, fine by us. Now, let's go ahead and figure out how many square inches this wall needs to be. So here, we're going to take 85 and multiply it by 420. And what do we get here? Besides a whole load of hungry and lazy workers. All right, 35,700. All right, so this is going to be square inches here. All right, now we have to figure out the bricks. So let's do the bricks. So we're going to do 4 1/4 or 4.25. And we're going to multiply that by 8 3/4, which is 8.75. Yeah, cool. All right, so far so good, you guys. Nice. All right. So those are the amount of square inches that we have in the wall here. So how about the bricks? How many square inches per brick does this cover? We got 4.25 times 8.75. What do we got? Hmm. 4.25 times 8.75. Hmm. 37.1875. Okay, that sounds good. All right. And then our last step here to figure out how many bricks we need, we're going to take our 35,700 and divide it by 37.1875. Okay. And what's our final answer here? 960. All right, good stuff. Good job, everybody. Nicely done. All right. So we need 960 bricks to complete the job. Nice. All right. Any questions about that? All right. Good stuff. All right, let's try another one. Okay. Okay. So this one here is going to be a bit tricky, but you'll see how we do this problem here. It's really not as bad as it seems, but we're going to see how it works out. So, okay. So let's check this one out. Boop. All right, where is that one? There it is. Okay. All right. So let's take a look here at this one right here. All right, so this is number 13. So this one here is a bit tricky, but let's just see exactly how it works out. Okay. So let's look at 13. A sheet of 25-inch by 38-inch paper must be cut into 6 by 8-inch cards. The cuts can be made in either direction, but they must be consistent. Which plan will result in the least amount of waste? Cutting the 6-inch side of the card along the 25-inch side of the sheet, or the 38-inch side of the sheet? And then see what the amount of waste that we make possible. So this one here requires a little bit of a visualization. I think that's definitely true here. So we have a 25 by 38 sheet, and we got to cut as many 6 by 8 cards as we can. But again, unfortunately, we're kind of limited because we can't just glue pieces together to make 6 by 8 cards. It'd be nice, but it would look pretty bad. So let's get a picture here, first and foremost, of a 25 by 38 paper. So let's just draw it. All right, go. Okay, so down on this side here will be 38, and we'll put over here 25. Okay. Now, if we're cutting on which side here, can we cut? We can cut either on the 6-inch side, which would mean we make cuts this way, or we cut this way on the 38-inch side. So we're cutting the 6-inch side here either down or across. Okay, so let's take a look at which one will reduce the amount of waste based on how many cards we can make. Okay, so let's make a 6-inch card down this way. So I can basically go 6 down here. So let's say this is a 6 by 8. All right, and another 6 by 8, and another 6 by 8, and another 6 by 8. Now you're probably saying, how did I know that there were 4 of these cards? Well, this is 6, 6, 6, and another 6 here. That would be 24 inches if I would cut along the 25-inch side. That leaves me with 1 inch left over. And then I can repeat this all the way down for the 8 inches that would be across here. So how many would be 8? 4 of them. So again, it's not the best representation, folks. Don't take my drawing. If you consider my drawings terrible, you have done a very good job. All right, so my drawings are pretty bad, but you get the general gist. So there's 4 cards here, 4. So we could make looks like 16 cards here. Okay, so that's cutting it on the 6-inch side. Okay, we make 4 down and 4 across because again, 8, 8, 8, and 8 is 32, and we can't fit any more beyond that, unfortunately, because we can't make 8 inches over here. Okay, so that's the first one. Really quick, are there any questions about that? Any questions at all? Okay. Okay, let's draw another picture. Same dimensions. Okay. So you got 38 and 25. This time, though, we're going to cut our 6 inches along the 38-inch side. So we're going to have 1, 2, 3, 4, 5, and 6. So we have 6. In this case, this is 6, and up here is going to be 8. Okay, so this is a 6 by 8 card. Okay, now we could take 6 cards because, again, that would be the maximum. 38 divided by 6 would be 6 with some remainder here. That would be our scrap. And here we have 8 inches going up, and we have 25 inches on the side, so we can make a maximum 3 cards. So just like so. Let's put 3 cards here. Okay, so here's the amount of cards that we can make if we cut on the, we cut 6 inches on the basis of. Sorry, I should have added that. Okay. So let's see here. We got 1, 2, 3, 4, 5, 6. We have 18 cards here. We have 1, 2, 3, 4. We have 4 times 4. We have 16 cards here. So 16 cards from the first one. And looks like 18 cards from the second one. Okay. So what we know for a fact is that the one that maximizes the most, at the very least, is going to be the one that has 18 cards total. Now the question is how much scrap is left over after we take the 18 cards away. All right, so let's take a look. So we have 8, 8, and 8. That takes up 24. All right, that's 24 there. And we have 6 all the way down to here. So that's 36. So our area for our cards here specifically is going to be 24 by 36. That's how many the area in cards is going to be. We go ahead and do that out. So that's going to be 864. And all we have to do is find out the area of the sheet, which is 38 by 25, which is 950. And we just subtract. So 950 minus 864. So we get 86 for that. 86 square inches is the waste for that. Are there any questions about that? Any questions at all? Again, feel free to ask if you have any. That one's a little confusing, I know. Okay. Go. Okay. So, okay. So if there are no questions about that, can I do another one? Yes. Yes, I can do another one. Yeah, right? Let's do another problem then. That is perfectly fine. I don't have a problem doing that. Got lots of time. Okay. No problem, my friend. Anytime. Okay. Which one would be good? Oh, okay. That one's actually really good. All right. Let's do this one here. So it's on the next page. All right. Okay, so we're going to do number 26. Okay. So we're going to do number 26 here. All right. So let's go ahead and do that here together. So 26 says a tensile specimen had an original rectangular cross section measuring 0.615 inches by 0.188 inches. After a pull, the cross section measured 0.506 inches by 0.094 inches. What was the percentage reduction in the area? Okay, so in this case we have some random cross section. We do a pull, we want to weld that, we do a pull, and now the cross section measures significantly different than it did before the pull. Again, just probably putting the two pieces together, we're going to lose a little bit of material. Okay, so we're given, we want to find out what the percent difference is from the before and after, essentially. So let's go ahead and do the area for before we did the weld. So let's figure that out. So we have 0.615 times 0.188 Okay. And can anybody tell me what we get here for this area? What we get for this area here? Go ahead and multiply that on the calculator there. Anybody can give me an answer here? All right, 0.11562. Okay, that's all right. Now we do want to be exact for this. This one's actually important to have exactness. So that all the decimal places there, I think. I think that should be, because I think it's 5620. All right, so we don't want to round here in the middle. All right, Axel. So the reason why we don't want to round here in the middle of the process is because we're dealing with really small areas. And because we're dealing with really small areas, even a minuscule amount of rounding could actually end up to be either skew your percentage reduction. So that's why we actually take the exact answer here as opposed to a rounded answer. So that's why I'm going to use 11562. The only time we round here is pretty much at the end of the problem. Then it's okay to round, but not in the middle of the process. So we want to avoid that as much as possible. Okay, let's do the after. So after the pull, uh, what was the area of what was the area then? Small is relative. Uh, oh boy. If you're looking at real world examples, small is not relative. It's an definitely exact science you want to be in, especially when you're trying to make things that require to be things in millionths of an inch. Imagine if you have to give something to a grinder and they're off by just say even a thousandth of an inch. They'll laugh you right out of the building and they'll tell you never to come back. You'll have lost and wasted all that money and time. Small's not a given. So it just depends on the context of the situation, and especially when you're talking about material, you want to make sure that the project runs along. Was I taught to use more significant digits in the calculation? I mean, basically at the end of the day, I don't. Basically at the end of the day, you could use more significant figures in the calculation, and I just use all of them because I want to be sure. I want to be double extra sure that I have the exact precise answer at the end of the day. Oh, no problem. It's all good. I take nothing for granted when it comes to mathematics. Okay, that's fine. One thing about mathematics I don't do is I don't assume anything in mathematics. I'll do it to the last, and then if they want it rounded at the end, then we do it at the end. But we don't do it in the middle. You'll find out that actually that sometimes occurs doing homework problems as well online. So we get here 0.047654. Okay, so what we're going to do here is we're going to find out the percentage reduction here. Now to do that, we just follow the good old formula here, new minus the old, and we'll divide that by the old. This is how we can find that percentage reduction here. So the new amount here is 0.047654 minus 0.11562, and then we'll divide that by 0.11562. Okay. Now, don't forget here, if you're putting this in the calculator, make sure you put this in parentheses first. Okay. Otherwise, it will not subtract first. It will divide first. And obviously, that's not what you're looking for there. So just be a little careful about that. Okay. So you will get a negative answer for this, and that's fine because it's a reduction. So here we should get 0.5878. Okay, so we go to 2 decimal places here. All right. All right, so we can round here at the end. We're at the end, so we can round here. So we have negative 0.5878. And really quick here, what's that as a percentage? What's minus 0.5878 as a percentage? Okay, good. So we have, again, minus 58.78%. That's good there. Okay, and that's our final result there. No problem. All right. Any questions about that problem? I hope that was I hope that cleared some stuff up there, Diego. So just another kind of example there. Oh, good. Making sure we get that down. Not too shabby crabby. All right. Okay. All right. Any more questions before we move on? No? Okay. Let's go ahead and move on here to the next part. Okay. So we're going to go ahead and skip section 8.3, like I mentioned here at the beginning. Are you the only one that needs a nap right now? No question. Just what are you implying there, Gustavo? I know I'm boring. I know I am. All right. You don't have to rub it in, man. Don't have to rub it in. Let's see. Hang on. Let's get some let's hope I don't get wrecked with it. So let's see. Hopefully this works. Um, okay. Yeah, I know they need a wake up song. Low key, me too. Don't sleep in class when you have to listen to my voice. Like, good. So I had a bit of an issue, like editing out some music and stuff. So I'm like, okay, like the replay won't be very good if I do this, but we're gonna try. I'm gonna try, see if this works with copyright-free music. That's what I've looked up on YouTube. Just all I want is like copyright-free music, because I'm just like, okay. Um, wait, I need a hmm. What do you think? I can't do that. I gotta do something else there, right? Let's do this. Kyle. I gotta decide. Something here. I'm gonna take a chance, I guess. All right, we'll go with rock metal, I guess. Does this work? 10 burpees wake you up this. I'm sorry. I'm sorry. There. How does that sound? I just found it on YouTube. Well, yeah, that's the idea. It's supposed to be kind of faded in the background, so you could hear me. Okay, let me turn it up a little bit. Okay, I'm gonna try. This, like this. You guys are jerks. All right, you know what? No. Let's do it this way. Let's do Eurobeat, okay? Let's just do Eurobeat. Let's do Eurobeat then. Oh man, this'll be our little break. Might have to edit this out later, but okay. That's that's true. Oh my gosh. It's true. Let's see here. Oh shit, you own an 8086? Those are super hard to find. They don't even make them anymore. Insta. You're a baller, Tao. Yeah, Tao, I need a picture. Not a stock one. For those of you who don't know what an AA6 looks like, this is what one looks like here. So there you go. An AE86. Look at your Insta. What's your Insta? Damn. Damn. Alright. That's legit, bro. Completely legit. I gotta see this for myself, man. I gotta see this for myself. Oh man, that is sick. That is sick, bro. That is sick. He ain't kidding. Holy cow, that thing's gotta run like a dream. Oh man, if you tuned it that well, holy moly. Very impressive. Very impressive, man. That's very impressive. All right, now I gotta put that on pause. All right, I'm very impressed. That is a that is a fucking amazing car right there. Much props and love. Oh man. Well, that made the whole class right there. You have an AE86. Dang. You truly are Takumi. I can't say bad things now. Can't say bad things. Holy moly. All right. All right, guys. We got to move on though. Got to do it. All right. Let's move on. Well, all right. Let's move on, guys. So we gotta do the next section here, section 8.4. I'm not sure I can beat that. That's uh, that's something that may be impossible for me to beat. You know what? If he woke you up low key, he did his job. Oof, mercy. Wow. All right. Next, next we're gonna talk about. I can't really top that with that, but I gotta go through the material anyway. Gotta go through it. All right. Next, we're gonna talk about circles. All right. So I know this pales in comparison to anything related to that car, but we're gonna have to try our best. All right. Let's talk about circles here, and let's discuss what we're doing with circles and everything like that. All right. So here we got a line. All right. Coming out here. Now, parts of a circle here are pretty easy to tell, so it doesn't take too much to do. So here we have a D here, we have R here. So first of all, we have D here is a diameter. Okay. R here is radius. You've probably heard this before many times, but still radius. Again, radius here is equal to the diameter divided by 2. Okay. So most of the time, what we'll be doing here as for formulas here in this particular section, what we'll be doing for formulas here is we'll most of the time be using radius. All right, diameter is used sometimes, but honestly speaking, radius is used a majority of the times when it comes to, say, mathematical formulas and how you apply it. So um, it's just usually radius is the thing, but it doesn't mean you can't use diameter. It just means sometimes it looks a little more awkward with diameter in the formula. Okay, now with this circle here, we're going to define two things. We're going to, of course, define the perimeter, which of course has fancy words. All right, so let's take a look here at the perimeter, or not so much as the perimeter here. We're going to talk about the circumference. Circumference is just fancy for perimeter for circles. Okay, so what is the circumference here? Okay, so let's write down the formula. All right, so here we get circumference here is going to be 2 pi r. All right. Or another way to write this would be circumference here would equal pi times diameter. So another way of just expressing them with diameter, you can express it this way. They have the same exact meaning. All right, so that's circumference there. No problem. Okay. Now let's also talk about area of a circle. So what about the area of a circle? So the area of a circle here is going to be a little different, but we're going to go ahead and write this out here. So the area here for the circle is going to equal to, let's see, here we go, pi r squared. So pi r squared is one way to define the area of a circle. This is the most common one. Or, again, a second way you can define this, which is not used so often because it does look fairly awkward, but it's pi times diameter divided by 4. 5 times diameter squared, I should say, divided by 4. So if you use this, this would be another way to express the area of a circle with just a diameter on its own. Okay. All right. Okay. So we have circumference and area, and we're going to solve some problems here using these two little dudes, all right, in order to basically get the area here. So there is, let's see, I maybe want to do one more. All right, okay. Let me go ahead and put in one more here that they happen to throw into the book here, but I'll state it for the sake of stating it. All right, so the area of a ring, or it's called an annulus here, but area of a ring, and so the area of a ring has two things here. It has capital R, which is the larger radius, so this is the radius of the outer circle. Little r here is the radius of the inner circle. All right, no, not two r's, I want little r here. Okay, all right. And if we want the area of a ring, then that area here is going to equal to, and as you can see there, it's a lot easier just to use the r's here. So pi little r squared. Okay. Okay, so that's the area just like so. It's not too bad. There you go. Good beans. Okay, so let's take a good look here at a couple of problems here about how to solve for area. And there are actually a couple of problems that going to be a little bit tough here, so we'll see exactly how it works out, but it's not as bad as you may think. So let's take a gander here, of course. Okay. All right. So we have those, and that's okay. We're gonna kind of bypass some of these. Okay. So let's take a good look here. Which one I want to do first? Yeah. Okay. Let's look at this here. Okay. Let's look at number 13. Okay. It says find the length of stock needed to create each shape. Round to the nearest tenth. Okay. So we want to go ahead and solve to see how much stock. This is the book. This is the book's representation of wiring. So just to let you know, that's the book's representation of wiring to some extent. And we want to find out how much the length of stock it's going to take to create this circular shape that we have right here. Now there are a couple of ways to approach this problem, but there is definitely one way to approach this in a much easier fashion. So let's go ahead and see what we got. Okay, so you notice here that we have the diameter here of this circle is 9, okay? And we have the inner diameter here to be 7. Okay, so what that means is in this case, we can either find, we don't want to find the area here because that's not what we're looking for. What we're looking for here is we're looking for the circumference in order to find the length of stock that's necessary in order to pull this off. All right, so let's go ahead and take a look here on how we can do that. All right. Okay, yeah. Make sure about that real fast. Yes, okay, that's fine. So let me go ahead and show off French toast. I can certainly help you out with some math. That's not a problem. I just need to finish a few problems here. So, but I'm not sure what you want to ask me. So, yeah, that's what we're doing. We're kind of doing right now. Go ahead and whisper me your question, and I'll answer it for you. All right. So as you can see here, um, we have a wire here that's in this case, it's not 2 inches thick. This will actually be 1 inch thick. Okay. So this is 1 inch thick right here. The reason why is because we have 9 inches minus the 7 inches on the inside. So this stock is going to be 1 inch thick at the end of the day. So because we have that, we have essentially 7 plus 1, which is going to be 8 inches here overall for our radius. For our, sorry, our diameter here. I gotta get that right. No, that's still correct. Does it still have, no. Yeah, that's right. Okay, okay, yeah, okay. Okay. Sometimes I have to question myself. I'm like, what am I doing? I'm like, oh, yeah, that's what I'm doing. Okay. So I'm going to show you how to do this problem here. And the book doesn't do a great job of explaining this, so I'm going to have to go through this a little bit carefully. Um, the book's kind of poor about how they approach this problem, so in particular. So let's take a look at a select problem here and do it. All right, so here's our picture here. Now, one of the things that's important as part of this particular problem is that, again, this is given to you as 9 right here. All right, and then on the inside here, we're given as 7 as this inside diameter. However, the one thing that we're going to look at here is we're going to look at the radius. Okay, so this is the radius here. It goes out to here, and then it goes out an extra little bit. Remember, the radius is all the way out to the very outer edge of the circle. Okay, so for us to figure out how much this is going to work out, we're going to use our circumference, which is 2 pi r. Now the question is, what's our radius? Well, we know that the internal radius is half of 7, because 7 is the diameter on the inside here. We also know the difference between 9 and 7, which is 2, which means that if we have one side over here, and let's say one side over here, this needs to be 1, and this needs to be 1. So actually, our radius here in this case is going to be 3.5, all right, times 3.5 plus 1, which is equal to 4.5. Okay. Okay, I'm going to get to that question next. I'll show you how to do that. All right, so in this case here, I'm going to have 2 times pi times 4.5. Or again, this will be 9 pi. Okay. Better make sure that's 9 pi. Yeah. Yeah. All right. Let's make sure about that one more time. I always get a little confused about that one. All right. And 9 pi is, what's 9 pi going to be? All right. 28.27. Okay. There we go. So that'll be 28.27 square inches here, or yeah, inches actually, I should say. Okay, so that's how we get that answer for that problem. Are there any questions about that? I'll do your question next year, French toast. Any questions, guys, before we move on? Nope. Okay. All right, French toast. I'm gonna do your question here right now. Okay. So let's go ahead. I was just gonna say I was gonna do your question that you posted there. Okay, let's do Toast's question, and we'll see what we get here. So this is something we actually talked about, so it's a good review nonetheless. So let's put your question down here. No problem. So we got 4 times 2x minus 2, all right, equals 8 times 2x plus 5. Okay. So remember your goal here. Remember your goal here, Toast. Your goal here is to get x by itself. Now, I'm going to be honest with you here. Actually, I'll let the other guys kind of answer this for me a little bit. All right. So, guys, can you guys tell me what was the most important part of algebra? What's the goal? What's the most important part of algebra? What did I say was the most important part of algebra? Correct. Very good. So if you want to get to know anything about algebra here, balance is the #1 thing. That is the key to all algebra, my dude. The key to all algebra is balance. If you remember this one word, then you will have a nice time of algebra. Yes, remember that. It is very, very helpful because once you understand that you have to basically balance things out, then it will help you to solve for that variable x that's confusing you so much. Okay? That's very, very important. I've drilled it into these guys' heads, and they've done really well with the algebra part. Okay? Definitely true. All right? Now, let's think of it this way, Toast. All right? We have 4 times 2x minus 2 and 8 times 2x plus 5. You're going to say polynomials. All right. So what we want to do is we want to get x is equal to some number, okay? But that's the goal. We get x is equal to some number, that's going to be our answer. But we got a lot of roadblocks in our way. Now, the first thing that we're going to do here in this problem is we're going to distribute the 4. So we're going to multiply 4 times both things on the inside. So we get 4 times 2x, which is 8x, and 4 times minus 2, so be careful of the signs, okay? So again, one thing I will point here, again, key 2, again, be careful of the signs. All right, very important there, all right? I'm going to make this bigger so you can see this a bit easier. Okay, so be careful of signs. So we have a positive times a negative, 4 times minus 2, that's going to be minus 8, okay? Positive times a negative is a negative, then 4 times 2 is 8. And that's how we got that left-hand side. All right, any questions so far, Toast? Take a little time to get there. It's in the UK, but it's okay. Nice. I appreciate that, Gustavo. Okay. You don't have to call me sir. You just call me Chibs. It's fine. Or Ollie or whatever. All right. All right, next, we're going to do the same thing here on the right-hand side. We're going to have 8 times 2x and we're going to take 8 times 5. Okay, so we have 8 times 2x, which is 16x. And we have 8 times 5, which is 40. Now, here's the important part, okay? Here's the important part. So let's talk about this. In order to solve for x, we want all the x's on one side and all the numbers on the other side. That's what we want to do. Put all the x's on one side and all the numbers on the other side. Okay? That's what we want to do. All right. Now, in order for us to do that, to make sure we have all the x's on one side and all the numbers on the other side, we're going to play a little game. That game, of course, as you see, is already written. We're going to balance things out. So, much appreciated. So what we're going to do here is let's take care of the numbers, okay? So we can make an arbitrary decision here, okay? We can say, I want to say I have -8 here, okay? And I'm going to go ahead and do the opposite of -8. Okay, that's what I'm going to do here. The opposite of -8 is +8. Okay, so I'm going to take +8 right here, my friend. Okay, but because of balance, okay, remember, everything in algebra is always a balance. What I do on one side, I have to do on the other side. So if I add 8 here, I also have to add 8 here as well. Remember, always a balance. That is the #1 key. And it definitely shows itself here in this problem. So let's take a look at what we have here so far. Okay, let's take stock. Right now, we have 8x, because I didn't touch that. I have the 16x here. I didn't touch that either. And then now I have 40 plus 8, which is 48. Okay. All right, Toast, you with me so far? Everything okay? Let me know. I'll give him a little time. I know it's a little bit of lag from there, so. Just to let you know, Toast, we're not quite done just yet, but we're getting there. Okay, awesome. All right, glad we're here with me. Good. Okay, let's talk about what we need to do next, okay? So I don't want two x's. I want an x. I want x's on one side of the stuff, and I want numbers on the other side, just like I mentioned here before. So my current roadblock here, oh, that's okay. You can, all right, that's just fine. It's all good. All right. So what's next here is that we have 16x. 16x is in my way. I don't want that there. I want it on the other side because I need all the x's on one side. No matter if that's positive or negative, I don't care. All I care about is x's on one side and numbers on the other side. So since I have plus 16x here, I'm going to subtract by 16x here. But of course, balance requires me to subtract 16x here on the other side as well. So now I've gotten rid of the 16x's. We're good there. And now I have 8x minus 16x. Now remember, in these problems, you can get negative numbers, and that's fine. So we have 8 minus 16. That's going to be minus 8x. And now we have almost what we want here. Getting very close. Okay, so we have minus 8x is equal to 48. Okay, that's what we got here. All right, so we're almost there to getting x by itself, but we have another roadblock in our way. All right, as you can see here in this problem, we have the minus 8 times x here. That's no bueno. okay? We don't want that. Okay, that's not fun. So instead, we need to do the opposite of multiplication. And the opposite of multiplication, again, is going to be division. So let's go ahead and we'll put this in green. So we'll divide this by -8 because I want to get rid of everything except for x. Okay, I want to leave x alone. I'm multiplying by some number here. So in order to get rid of it, I do the opposite thing. I divide by that number here by -8. But once again, balance. I got to balance things out. So if I divide by -8 on one side, well, guess what? I have to divide by -8 on that right-hand side as well. So this effectively cancels out, and that leaves me with our final result here. X is equal to 48 divided by -8, which is going to be -6, which will be our final answer for this problem. Are there any questions, Toast? Feel free to ask, okay? Any questions, you guys? Hopefully that was a little bit of a review from Chapter 6 and Chapter 7. We talked about some algebra there. Just to let you know, yes, there might be questions with algebra on the test. You guys, no! Oh, things happened. Wow, thank you for the, thank you, Ground Kicker, for hosting. I really appreciate it. Thank you very much. It's very kind. Okay. I'm not sure UK time goes with American Central Standard Time. I'm not sure how that works out. But feel free to come on my stream when I am online, and then I'll be happy to answer your questions there. I do have an open time, open kind of mic time-ish sort of thing between tomorrow, between 12:30 and 3. There's a test? Okay. I tell you what, Toast. Why don't you hang out here for a little bit? I'm going to finish up my class here. I'm going to do a few more examples, and then I'll help you out with any more problems that you need, okay? Yeah, it's pretty early in the morning getting that last minute studying in. All right, but if you give me a little bit of time here, and if you can wait a little bit of time, I can certainly help you on more problems, okay? All right. Okay, guys, let's go ahead and move forward because we do have some. Oh, do I give tests to people? Yes, I do. Yes, I do. Oh, this is for a college course, my friend. So, there you go. All right, there we go. All right. Good stuff. Okay. Hey, anything to help, my friend. Anything to help. Again, as I've said to everybody, it's not about me, it's about you. And if you can be better at a subject that you have a little bit of tough time with, I'll be happy to be there for you. No problem. No questions asked. All right. I gotta do this next example. Oh my gosh. All right. Okay. Next, let's go ahead and do number 6. All right. That's the next problem here that I want to do. So, number 6 says, in this piece of steel shown in the figure, uh, 4.5-inch diameter holes are drilled in a 22-inch diameter circular plate. Find the area remaining. All right, and says use 3.14. Not a big fan, but whatever. All right, so we have 4.5-inch diameter holes drilled in this circular plate. All right, sure, no problem. Take your time. All right, so tell me, what should we do here for this? What do you think we'll need to do in order to find the remaining area from this 22-inch diameter circular plate? It sounds like a plan. Okay, so think about it this way, guys. Think about it this way. So we have just a giant disc, and then we have like a machining tool basically drill these 4 holes in there. So if we take the area, think of the area of the ring. All right, we take the full area of this 22-inch disc. Okay. Yeah, we also need the sum of the holes as well. And that's correct, Ivan. Absolutely. Now, okay, Miguel, one thing that we have to be careful about there is that although we have 4 of these holes here, the thing is that we cannot subtract the radiuses from each other. And that's only because the fact that we don't know what's the radius between here, and we don't know the extra length here. So we, instead of finding these little parts here, which is going to be very difficult, we'll take the whole area of the disc, the 22 inches, and then we'll subtract by the 4 holes of 4.5 inches each. But we need to find the area of each first before we actually, do that. So let's go ahead and take a look at how we can do that here. So using our area equation, since we're given again, don't forget this is 22 inches of diameter, okay, for this guy. Remember that the area here is equal to pi r squared, okay? So be very careful about this. Context matters here, okay? Context matters a lot, and that looks pretty terrible. So let's erase that and try again with pi. All right. So let's understand this really quick, is that the diameter is 22 inches, but the radius here is 22 divided by 2, which will be 11. So again, just being a little extra careful about how we actually approach this. So we have pi times 11 squared, okay? So just letting you know here, that's what we have, okay? That's the area of the big disk. So next, we have each of the figures have 4.5-inch diameter holes. So each hole is 4.5 inches in diameter. All right, welcome back. Okay, no problem. We're just going to get through a few more problems here, so please feel free and watch. All right, so if this is 4.5 inches in diameter, what's the radius of the circle? So if this is 4.5 inches in diameter, what is the radius of the boreholes here? All right, 2.25 is correct. Okay, very good. So 2.25 inches is the radius here. So if we want to find the area of each of those, the area of one of those holes is going to be pi times 2.25 squared. And then, after that, we're going to multiply that by 4 because we have 4 boreholes in this particular piece. So let's use our calculator here for just a second. All right. So I'm going to kind of cheat a bit, and I'm going to do a little trick here for myself. That's 121 pi, so that's fine. 4 times 2.25 squared. Okay. So this is 20.25 pi. So one of the little tricks you can use here is if you don't want to incorporate pi because it's a long decimal, what you can do is you can take, in this case, 121 pi minus 20.25 pi. And actually, they act like terms. So you can actually get here 105, no, not 105, 100, I should say. What am I doing? So 100.75 pi, which will net you the same answer here. So we get 100.75 times pi, and if we want the decimal answer here, that'll be 316.52. Okay. I think this is square inches, right? Yeah, square inches. All right, so 316.52 square inches is what we have there for that problem. Oh, no problem, Toast. Thank you very much. Thank you very much for coming on by. Hey, have a wonderful night, okay? You take care of yourselves. All right? Again, if you ever need help, feel free to stop on by. Well, if you have a test soon, then come on back. If I'm online, just ask. You're lost on this one. Okay, where are we lost, Ivan? Let's go ahead and talk about it one more time here then. You get 15.54, okay. Okay. Are we talking about, Gustavo, or guys, are we talking about the radius of the smaller one or the radius of the larger one? Or you guys understand the radius, but what happens after that? Okay, okay. so let's talk about the area here, all right, that we took away from this figure. Okay, let's talk about that. So we know that the area of the larger figure is going to be this, 121 pi, okay? So that's what it's going to equal there at the end of the day. What we don't know is how much of the area did we take away? Well, in this case, we did know that 4.5 of a diameter equals 2.25 a radius. Now, what I did do here is we took the area equation, which was pi r squared. All right, so this takes care of the pi times the 2.25 squared. This 4, on the other hand, represents the 4 holes that were actually in the picture. So this is 1, 2, 3, and 4. Okay, so that's why I multiplied by 4 here, and then I multiplied 4 times 2.25 squared. Remember, this is a square here, 2.25 squared. So this is not times 2 here. This is to the second power. Put that as an exponent there. And that's how I came up with 20.25 pi. So then I took the bigger area and subtracted it from the smaller area, because that's what we took out. And then I was able to get my full area here of 316.52. So you can like type this in your calculator and you should get the same answer here. Okay, so you got this right-hand side right here, Ivan. You got 20.25 times the pi. That's what you got there, all right? You're going to take that number and subtract it from 121 pi, because that's the area of the bigger circle. Why are we not multiplying by pi? You can if you want. So do it on your calculator here. Do 121 times pi, okay? So 121 times pi minus 20.25 times pi. So you could multiply both of those on your calculator and you'll end up with the same answer that I have here on the screen. The reason why I didn't multiply by pi here right away is I didn't really want to deal with too many decimals here. So you can actually use it as like terms, pi as like terms, and actually subtract first before you actually multiply by pi. That's why I went ahead and did a little bit of a shortcut there. But I apologize for confusing you there. So that's essentially what's happening in that problem. Okay, cool. Any other questions about this problem here? Hopefully now it makes a lot more sense. You're not seeing how we get 20.25? Okay. So you agree that the radius here was 2.25 for the smaller holes. Okay. So 2.25 was the radius for the smaller holes because that's half of 4.5. Okay. So we use this equation here of pi r squared. So we have pi times r squared. You get stuck at the 15.90. Hang on a second. Where are you getting the 15.90 from? I'm a little confused. Start from the beginning there, Gustavo. Okay? Start at the beginning. Use 121 times pi. And then you're going to use this equation here, again, 20.25 times pi, and subtract them from each other. The 20.25 comes from the 2.25 squared, which is the radius, times pi, times 4 for the 4 holes. Yes. And then multiply that by 4. Because you have 4 holes in the picture. I hope that makes sense. There we go. Okay. All right, that one's okay. All right, it's fine. Okay. Did you follow what I have up here of what I wrote in chat? Try that. Yeah, I'm not sure what you're doing wrong on the calculator there. I'm not sure at all, actually. I'm a little confused. All right. Well, let's go ahead and finish off Chapter 8 then. Let's go ahead and do that. That's fine. We should be okay. That's just 3, right? Oh, yeah, that's right. That's right. Okay. Okay, good. All right. Okay, I'll help you out if we're getting a little more confused. That's fine. I'll help you out after we're done here. So that's okay. Okay, let's do one last problem here though, and let's do this one here, number 17. Okay, so let's look at number 17. Oh no. Well, I'll help you both out after we're done here. So. All right, carpentry. The circular saw shown in the figure has a diameter of 18 centimeters and 22 teeth. What is the spacing between the teeth? Okay, so in this particular case, we want to find in this case, the circumference of this gear, or a circular saw, I should say. So we need to find the circumference here. Now, the circumference here of this particular shape, and you know what, I'm going to do it on here. All right. So the circumference here, remember, is equal to 2 times pi times r. Okay, that's not an at. All right, so 2 times pi times r. Now, can anybody tell me here, based on this example, what is the radius of this? What's the radius of this saw right here? We have a diameter of 18, but what would be the radius in this case? All right, 9 centimeters. That's correct. Very good. All right, so we're going to have 2 times pi times 9. Okay, since 9 centimeters is half of 18. So now we're going to do that on the calculator here. Okay, so let's see what we get here. So we get 2 times pi, 2 times pi times 9. So here we have 56.54867. Now I'm taking it out here just a little bit to get it a little bit more exact because we'll need to do one more step here anyway. Okay, so what is the last step that you think we need to do here? Because our goal here is to find the spacing between each tooth in the saw. So what do you think we'll need to do last here in order to find that spacing? Well, they tell you how many teeth are in the saw here. They tell you there are 22 teeth here. So they do give you that value. So we don't have to count. They do tell you how many teeth are in the saw. So what should we do with that 22? Yeah, so the real question is, what are we doing with that 22? So we now know the circumference, and we're spacing it out 22 ways. So this one here, okay, I know this one's a little tougher, but okay, good. That's right. We are definitely doing that. All right. So let's go ahead and divide by 22 because we divide by 22 teeth. Okay. And then that should tell us the space between each one of the teeth on the saw. So we're just going to take that, divide it by 22, and we get here, what do we get here? 2.57 inches. This is inches, yeah. Oh, centimeters, sorry. This is centimeters. All right. 2.57 centimeters is the distance between each tooth, since they're spaced out evenly. All right, questions about that? No? Okay. The diameter was given to us here in this problem, Diego. It told us the diameter was 18 centimeters. So that was a given value. Oh, I got the 9. That was the radius. So remember that the radius is equal to the diameter divided by 2. So the radius in this case was equal to 18 divided by 2, which equaled 9. Yeah, no problem, Diego. All right, any more questions before we end off here for today? I know that you guys had questions about the last example, not this one. Any more questions, gentlemen and ladies? No? Okay. No? All right. All right, so this is where we're going to end off here for today. Okay, next time we're going to do chapter 9. We'll finish up with chapter 9 here. There's only 3 sections there. We will be skipping one section in chapter 9 as well. So that won't be reflected there. I'll let you know. It's the last section of chapter 9 that we're going to be skipping. So we're doing just the first 3 sections of chapter 9. So we should get that done by, again, Monday. And then we'll get into chapter 10, and then that's the end. So of the book. Yeah, there you go. So yeah, we're almost there for the people in the 8-week class. Yeah, we're almost there in terms of the material. So yeah, we're in pretty good shape actually. So no problems. Now, Gustavo and Diego, do you guys have any questions from the example with the rings? Because it sounds like you guys had a tough time with that. So you got that. Okay. Do you guys need any help? Yes. Okay. For the chapters we skip, yes, of course. I would never give you assignments that will that of any sections that we skip. Those will be automatically gone. Yeah, sure, of course. Here you go. Yeah, so remember you're multiplying pi here twice, okay? Okay, guys? You're doing 121 times pi, and then subtracting that from 20.25 times pi. So you're putting in pi twice. So on your graphing calculator or something to that effect, you should have, let me see if I can get this up here. Um, so you should have it look exactly like this. Okay. So that's what you should have there for that. You need help on the right side. Okay. So what do you have on the right side there, Gustavo? Okay. All right. So let's talk about this part right here, Gustavo. All right, this is where we're at here. Okay. You got this. All right, this is where we're at. But here's the next part. So I use the area equation again for the radius of each of the holes, and I'm going to go back here for a second. So as you see, there are 4 holes here in this particular guy. Now the thing is that I want to find the area of one of those holes because each one of these holes is equal. Okay, so I want to find the area of one of those holes. I know that the radius, correct, that is right. That is why we have the times 4 there. So you notice I have times 4 out here. So I did pi times r squared, 2.25 squared, times the 4. And then that way that would take care of the area of all 4 of the holes at the same time. That's okay. All right, hopefully now it's a little more clear. Question mark? But you see how I came up with it, right? You can see the work in front of you, right, Gustavo? Maybe you're not doing squared. Yeah. Maybe you're not doing squared. Maybe you're doing times 2. Like you got to square it. So if you're going to square it on your phone, you got to take 2.25 times 2.25 again. So yeah, so maybe that's I'm not in front of your phone obviously. So try this. And then on the left side you have again 11 times 11 times pi. So then you subtract those values from each other. So first, like you could do the left side, like this is the first one, and then you could do the right side here. And then subtract them from each other. Did we get it? I hope so. Yes, that's right, Ivan. So your 63 is correct on the right side. It's just that you have to take the 11 times 11 times pi for the 380, and you need to subtract them from each other. Like, I think that's the step you're missing is the subtraction part at the end. You're 63.6, yeah. Yeah. Like, you can't forget the 11 squared there. That's the area of the actual figure without the holes. Okay. All right. Hopefully that cleared up everything. All right, ladies and gentlemen, I want to thank you all very much for coming out here once again to the stream. I hope you had a lot of fun here today. We're going to go over chapter 9 here for next time. All right. Will there be a question like this on the test? I don't know. Maybe, maybe not. Guess you'll have to find out. I gotta be evil at least once. Ba-da-ba-da-ba-ba-ba. Maybe not, please. Fair enough. I'll figure it out. Don't worry. All right, guys. You guys have a very wonderful weekend. All right. Please take care of yourselves. Stay safe. Stay healthy. All right. And I will see you all on Monday for some Chapter 9 goodness. All right. Have a great one, everyone. And we'll see you all later. All right. Take care, everybody. Email me if you need help. All right. Bye.